Again, welcome to lecture number 6. This is our lecture number 6, Mathematics 200, Business Calculus, NJCU. In lecture number 6, we're going to learn about chain rule and also the power rule. So our main objective is chain rule and also power rule. And we're almost done with derivative. We've started with the power rules, constant rule, sum and difference rules, product rules, quotient rules. So now we start with the chain rule that goes with the power rule. So first of all, we should understand the concept of a composite function. What we mean by a chain rule is that sometimes we may have an expression and we have to find the derivative of the expression in a function which is in another function. So the concept of composite function is that we have a function which is not in its most simple form. We have to again get into it more details. So a function inside another function is called a composite function. So this is an example of a composite function. If we have a f and g, lowercase f and g as functions, then the composite function g of f will be denoted as g open circle f. This is the composite of a function g of f, which means the function g, f is inside the function g, or the other way, f open circle g means the function g is inside f. Here the function f is inside g. So here it's more simple. So g composite f at x, it means in the function g, there's a function f at s. So you can see that if I have g at x, I'll replace x with f at x, which means f at x is function f at x is inside g at x. Or the other way, f open circle g at x means function g at x is inside the function f. So if f at x, we are going to replace the s with the function g at x. So with this idea, we can start with the chain rule now. So here we say we can also use the power rule that we covered previously in a chain rule to find the derivative of a composite function. So here we say we write the composite function y equal to f at g at x. So this means g at x is inside f in the form of y equal to f at u, where u represent g at x. We state this as the chain rule as following. So you see here we have a function what f and g, which are differentiable function with y equal to f at u and u equal to g at x. Then y is the differential function of x. If that is the case, then dy dx will give me what? F derivative at u times g derivative at x, because g at x is inside f at x. So we know derivative of f at u is the same as dy du. Then derivative of g at s will be du, then dx. And here we should know that dy du represent the derivative of y equal to f at u with respect to u. But du ds represent the derivative of what u equal to gs with respect to x. So now let's try this example, which may clear a lot of things for us. So when I have a function y equal to square root of x squared minus 1, they say we should find the derivative of x or dy dx. So here I can not only use the power rule saying that, okay, square root is the same as the exponent half. So we can say this is the same as writing x squared minus 1 exponent half. Then derivative of that will be half. Since the half is all exponent, half will come front. Then x squared minus 1 half minus 1, which will give us negative half. And that's the concept, but this is not the case. This is chain rule. Since this is derivative, and we can differentiate it, we also have to differentiate the inner of it, which is x squared minus 1. So let's see, if we write this function as y equal to f of u, which is the same as square root of u, and is the same as u raised to the power half. This is with respect to u equal to x squared minus 1. So here we have the y dx equal to the y du, then the u dx. So we can see how the chain rule breaking it more to simple form. So in this case, I can say this is x squared minus 1 square root is the same as x squared minus 1 half. So we can bring the half, then we say u, 1 minus half will give me negative half. Now this is where the chain rule comes. Times 2x. Why? Because the derivative of x squared minus 1 is 2. And this is the concept of a chain rule. So we cannot say, okay, since the function itself is derivable, we can find the derivative of it. We write x squared minus 1, the derivative of it, which will be 2x. Then we multiply by the original equation, which we were able to find half times u raised to the power negative half. So finally, we get our answer to be u to the power negative half times x. And we change this to positive exponential 1 over square root of u times x. And that will be our conclusion. Now next, to write this derivative in terms of s alone, we substitute x squared minus 1 for u. So this is another way of solving it. Instead of using the u, we are going to use x. So we know that x squared minus 1 for u, which will give us again, so which again will give us, to write this derivative in terms of s alone, we substitute x squared minus 1 for u. So you will get s over square root of u, and u is what? S squared minus 1. So this will be our final solution. Now the power rule, you can see here that we are using chain rule. Why? Because when we find the derivative of this, we have half. Exponent is half. So half times x squared minus 1, half minus 1, which will give us negative half. And that's what we have here. But we also have to find the derivative of the function itself, which is x squared minus 1, which will give me 2x. So let's go to the power rule now. We know the power rule. We said that if y equal to u to the power n, then derivative of y will be what? To be n times u to the power n minus 1. Then the y ds also. So the y ds will give me n times u raised to the power n minus 1 times the y dx. So here we are using the power rule. Now, if we have this question, we should be very careful because we have to use the chain rule. So we can see that y equal to 3 x squared minus 3x plus 1 raised to the power 1/3. So here we can say the power rule with u equal to x squared minus 3x plus 1. So the u will give me, 2x minus 3. So here you can see that we are using chain rule. We have a constant value 3, we didn't touch it. But inside here, we say n times u raised to the power n minus 1. Then this is chain rule, so we find the derivative of the u ds also. So here you can see we have 3, 1/3 u to the power negative 2/3. Then the derivative will give us 2s minus 3a. So 2s minus 3. Everything here is negative, so it goes down. So this is the b. They say we should write g at s as a power, gives g at s equal to s squared minus s squared plus 1 raised to the power negative 3/2. So here we know the rule, power rule, negative 3/2 s squared minus s squared plus 1, then negative 3/2 minus 1. So here we just have to simplify the expression. And then we get negative 3s square root of s squared plus 1 raised to the power 5. We also can use the demand function with the calc. So here they say the demand for S 100 unit of product is given by this formula, where P is the price per unit in dollars. And the question says we should find the rate of change of demand with respect to price when P equal to 24. So first thing we have to do again, find the derivative. So we find the ds, the P. 98 is there already. Negative half to P plus 1 to the power negative 3/2 times 2. So here we have negative 982P plus 1 raised to the power negative 3/2. When P equal to 24, the rate of change is P equal to 24. So 2 times 24 is 48 plus 1, and that gives us negative 27. So this means that when the price is 24, demand is changing at a rate of negative 27, 100 units per dollar. So again, that will be the conclusion for lecture number 6. In this lecture, we cover the chain rule and the power rule. Again, this is just a lecture. Then I will make a video and solving problems in this topic, which I'll even start from lecture number 1. We have having start solving problems. So again, wish everybody the best. Thank you. Bye. Also, this is a new channel. If you want to subscribe to it, comment, or like it, everything is welcome. Thank you.